In this video, we will go through the process of generating a Lineweaver-Burke plot from concentration and rate data for enzymatic catalysis. On the screen, you can see currently the concentrations at which the different rates were measured. It is important that when you put in your columns of data that you give them not only a label like concentration or bracketed S and rate, but that you also give the appropriate units so that as you're interpreting this data, you're able to then assign those values something of significance. If we were to simply go through and plot these two against each other, we could do that. If we go to Insert and we go to a scatter plot, you'll see that this plot is not straight. It is difficult to fit nonlinear data, particularly using software packages like Excel that have some limited functionality. In these cases, we plot inverse data. And so let me just set this aside. What we really want is to plot 1 over the concentration, versus 1 over the rate. This then gives us the setup for a Lineweaver-Burke plot. The math is fairly simple. You just select a cell, tell it that it's going to equal 1 divided by some piece of data. We can do the same for rate. So this equals 1 divided by the rate. We now see that we've got inverse data. We can then use this to then fill down the rest of our table without having to do the handwork of entering each of these. So now let's see what happens when we plot this data. So again, we're going to highlight the columns, we're going to go to Insert, and we're going to select a scatter plot. It's the one that looks like some dots on axes. And now our plot is beginning to look a lot more linear. A way to determine this is to apply a trend line, and we want to look for a linear trend line. Then when we look at the trend line, we want to look at the options for that. So we'll look at more trend line options. And there are two things we're going to want to check. The first thing is that we're going to want to put down an equation of the line. And you'll notice that as I turn it off and on, it shows up right here. And then the second thing, and this helps us know something about the linearity of our data, is to display an R-squared value. And you'll see that this data is very linear with an R-squared of quite nearly 1. We now, at this point, have a Lineweaver-Burke plot. You can use this to determine Km. You'll want to make sure that you've followed your units through so you know what these concentrations are in, as well as what the rate is. That is, how much stuff per how much time. You can also use this to determine your Vmax. One way to ensure that you don't get lost while you're doing this is to go through and tidy up the axes by putting labels. So we want a primary horizontal axis label, and we want a primary vertical axis label. And so just click it, double click in. This will be 1 over the concentration of substrate, and those units will be 1 over millimolar. Then we go to our y-axis. So highlight all of that, and that's going to be 1 over rate, which will be in the units of 1 over, well, simplify it, it'll be milliliter seconds per micromolar. The other thing that you'll want to do is update your title of your chart. So this is a Lineweaver Burke plot. And then you'd want to say of what data set. So you might have a specific enzyme that you're labeling it for, and this would be a place for you to do that. Again, the key here is that as we're working with our data, we want to know what our goal is. In this case, in order to extract enzymatic catalysis parameters of Vmax and Km, we need a straight line. So we need to do the double inverse or Lineweaver-Burke plot. Excel can help us do that. And we see the difference in the two different kinds of plots, the Lineweaver-Burke versus the simple concentration versus rate plot, which is nonlinear.